So 1.4, we still have our 2NO2 gas in equilibrium with the N2O4 gas, and we still have the forward reaction is exothermic. Okay, this is brown, that is colorless. Okay, now in 1.4 on page 177, they say a flask 1 contains an equilibrium mixture of nitrogen dioxide and dinitrogen tetraoxide, which is light brown. So this mixture is light brown. Okay, then they say the flask is placed first in hot water and then in ice. Decide which flask contains more nitrogen dioxide and which contains more dinitrogen tetraoxide. Then use Le Chatelier's principle to explain the appearance of the flask 2 and the flask 3. So basically flask 2 would look like flask 1. They've taken flask 1 and they placed it into hot water, and then they took the flask and they placed it into ice. So the first one is, what's it, 1.4, the first situation, so flask 2. Flask 2. What did they do to temperature?
They increased.
Right. If the temperature is increased, which reaction will be favored according to Le Chatelier's principle?
The endothermic.
The endothermic. So the endothermic reaction is favored. Which one is the endothermic reaction?
The reverse.
So the reverse reaction. So the equilibrium will shift to the
Yes.
hmm?
When we want to specify, when we want to talk about the shifting of the reaction, we must say equilibrium shifts the left. Because I just said
It will, yes. To reach new equilibrium, the whole equilibrium reaction shifts to the left. So your concentration of the nitrogen dioxide will increase. That's what shifting to the left means. The reaction speeds up to the left. Okay. So what will you see? That's why they give you the color. What will you see? The light brown color will change to what?
so, ma'am, the purpose of the color is just to visually indicate the
Yeah,
concentration.
yeah. So the equilibrium shifts to the left. Alright, so flask 3, you cool it down. Which reaction is favored? The exothermic one, which is the forward reaction. So the equilibrium will shift to the right. The concentration of the nitrogen dioxide will decrease, and the light brown color will turn a lighter brown. Yes. Do I have to write that down?
No, it's basically the opposite.
So you're okay with that?
Yes.
I think question 1.5 was more of a problem.
Exactly, because now we haven't really spoke about the pressure.
Yes. No, I didn't record this. The light brown gas will look darker, but by increasing the pressure, the shuttle here says you will favor the reaction that will exert less pressure. Which one will be exerting less pressure? The N2O4 will exert less pressure. Why? Because you've got half the moles, less particles. Less particles will exert less pressure. So you favor the forward reaction. So after turning darker, the gas mixture turns lighter. Because the equilibrium shifts to the right. The decreasing in volume you get.
Pressure,
Yes.
and then this, the gas becomes darker brown.
You get the darker brown story.
Yes, ma'am.
Okay.
Now, the increasing pressure
Well,
favor the reaction that will exert less
pressure.
pressure.
So it must make less molecules of gas.
I don't get that much. Ma'am, our forward reaction now. Okay, our forward reaction is from nitrogen
Nitrogen dioxide to dinitrogen tetraoxide.
Exactly.
Yeah.
So now, ma'am, we're increasing the pressure.
Yes. Increasing the pressure will put the 2 moles of nitrogen dioxide under stress.
Yes.
Where if they are under stress, some of them needs to leave. So they form dinitrogen tetraoxide. You favor the forward reaction because one molecule will be under less pressure. You decrease the pressure by changing 2 molecules into one. One molecule will have less chance of colliding than 2 molecules have. So collisions causes pressure. So if you make less molecules of gas, you have those gases exerting less pressure. So your brown gas will turn into colorless gas. So after it went darker brown, it will go lighter brown. So the current turns to a lighter brown. Because more of the colorless gas is formed. Because the colorless gas exerts less pressure. The second situation pulls the plunger out. Now that's got two effects on the gas. The one effect is that you're increasing the volume, and if you increase the volume of a container, this brown gas will look lighter. That's the initial thing you'll see. If you pull the plunger out, you're increasing the volume and you're decreasing the pressure. So initially, the light brown gas will go lighter brown. Okay? At that moment you pull it out, you'll see it goes lighter brown. Because of the increasing volume, the concentration of the gas is decreased. But unfortunately, this is a reversible reaction. Maybe I can demonstrate happen. Which reaction will be favored?
The reaction which will increase the pressure.
The reaction that will increase the pressure will be favored, which is the reaction that will increase the pressure. Which reaction will increase the pressure? That one, the reaction that makes more molecules of gas. So in this case, it is the reverse reaction. So decreasing the pressure will favor the reaction that will make more gas molecules. And that would be the reverse reaction. Because it forms 2 molecules for every 1 molecule of dinitrogen tetraoxide. So it will exert more pressure. Where you decrease the pressure, the reaction will try and oppose it. So what will happen to the color you see? So your concentration of nitrogen dioxide will increase. So your reaction will go a darker brown. That's what you will see. I can't do the temperature changes, but I can do this pressure volume change. Do you want me to do it for you?
Yes, please.
All right, let's